Imagine holding a single grain of sand at arm's length against the night sky. That tiny sliver of darkness it blocks. That microscopic patch of nothing you wouldn't even think to glance at twice. Astronomers recently aimed a $10 billion mirror directly at it. They chose a spot with no visible stars, no nearby planets, and no signs of anything worth pointing at by any conventional measure. Just black. Just absence. And what stared back is currently forcing physicists to rethink every assumption they have made about how the universe works, how it began, and how much of it we have been completely wrong about for decades. This is the story of what James Webb actually found. The unfiltered version. The one that made researchers quiet. The raw, uncomfortable, model-breaking version that scientists are still arguing about in conference rooms and late-night emails, because what Webb revealed is not just that the universe is bigger than we thought. It is that the universe is behaving in ways that should not be possible, and we are only now beginning to understand how much we did not know we were missing. Start with a grain of sand. Hold it up. In that speck of blocked sky, Webb found thousands of entire galaxies, ancient light from objects that finished burning billions of years ago. Galaxies. Each one containing hundreds of billions of stars. Each one a system of such unimaginable complexity that if you spent 1 second looking at each star inside just one of them, you would be standing there for thousands of human lifetimes. And that was one grain of sand. Pick another spot. Any spot. Different direction entirely. Thousands more. The darkness was never empty. It was packed. Every direction you look, in every ordinary patch of sky, the universe is heaving with structure, and we had no idea. But here is where the story gets strange. Because the light Webb captured from those distant galaxies did not leave recently. Light travels fast, but the universe is old and enormous, and the light from those galaxies left on its journey before this planet existed, before the star that warms this planet existed. Some of it left before most of the stars you can see tonight had even formed. Webb is not a telescope in the conventional sense. It is a time machine. Every image it produces is a photograph of the past, and the further Webb looks, the further back in time it reaches. When Webb stares at the most distant objects it has found, it is looking at a universe that was only a few 100 million years old, a universe that had no idea what was coming. No idea that billions of years later, a species on a small rocky planet would build a mirror and look back. That framing sounds poetic, but the practical implication of it is where the crisis begins. Because when scientists built the models that describe how the early universe should look, they made predictions based on everything they understood about how structure forms. After the Big Bang, the universe was a hot, dense soup of particles. It needed time to cool, to collapse under gravity, to slowly build the first simple stars, and then eventually the first primitive galaxies. The timeline was long. The process was gradual. The early universe, by every model we had, should look young, simple, unfinished. Webb looked to the early universe and found something else entirely. It found galaxies that were not young and simple. It found galaxies that were massive, fully structured, with organized spiral arms and distinct cores, the kind of galaxies that should take billions of years to build. And they were sitting there in the earliest chapters of cosmic history, fully formed, like a construction site that broke ground yesterday already has a finished skyscraper standing on it. Scientists have started calling them universe breakers, which is both a dramatic nickname and a fairly accurate description of what they do to the existing models. The first instinct was to look for an error. Maybe the distance measurements were off. Maybe the redshift calculations, the method used to determine how far away and how old something is, were being misread by Webb in a way that made ancient galaxies appear even older than they actually were. A calibration problem, an optical illusion created by the way the instrument processes light. Some researchers pushed hard on this interpretation because the alternative was more uncomfortable. That the standard model of cosmology, the framework that has guided our understanding of the universe for decades, was missing something fundamental. a fundamental gap in what we know about where everything came from, a missing continent. The optical illusion argument has not held up well. The more Webb images that come in, the more these impossible galaxies appear, and the pattern is too consistent to be instrumentation error. These galaxies are real, they are old, and they formed faster than any current model predicted was physically possible. That does not mean the model is entirely wrong. It means the model is incomplete in a way that changes the picture significantly, and the scientific community is currently in the uncomfortable middle section of not yet knowing what the correct replacement picture looks like. There is a second tension Webb has sharpened that existed before the telescope launched. Physicists call it the Hubble Tension, and it is exactly the kind of problem that sounds technical until you understand what it is actually describing. The universe is expanding, everything is moving away from everything else. Scientists have measured that expansion rate from multiple independent angles, with different methods, different instruments, different pieces of the universe as their measuring sticks. And the rates they get do not agree. The universe appears to be expanding faster in some measurements than others, and the gap between those numbers is too large to explain away as measurement error. Think of it this way. If you are running a simulation and different parts of the simulation are running at different speeds, something in the underlying code is wrong. The universe, according to our best measurements, is doing exactly that. The expansion rate disagrees with itself depending on how and where you measure it. It is as though different regions are playing by slightly different rules, or as though something we have not accounted for is pushing on parts of it in ways we cannot see. Webb has not solved the Hubble tension. Webb has made it sharper and more unavoidable, because now the data is cleaner and the disagreement is harder to dismiss. The picture that emerges from all of this is of a universe that did not build itself slowly, piece by piece, over tidy sequential phases. The universe exploded into complexity faster than the models allowed for. Structure appeared early. Massive galaxies showed up before they were supposed to have the time or the ingredients to form. The expansion rate is uneven. And threaded through all of this is a growing suspicion among cosmologists that something is missing from the standard account. Not a small variable someone forgot to carry, but a structural gap in how we understand the forces that shaped everything. Before getting to what might be sitting in that gap, it is worth pausing on the scale of the problem, the observable universe. The sphere of space from which light has had time to reach us is enormous by any human measure. So enormous that the numbers required to describe it stop carrying any intuitive meaning after about the third zero. But the observable universe is not the universe. It is a bubble defined entirely by the speed of light and the age of time. Beyond the edge of that bubble, space continues. The universe does not have a wall at the point where our light runs out. It just keeps going into territory where nothing that originates there has had time to reach us. Territory that exists in a physical sense but is permanently beyond the reach of any observation we could ever make. The stars you see when you look up at night are already ghosts in a specific sense. The light arriving at your eyes left those stars years, decades, in some cases thousands of years ago. Some of the stars you are looking at no longer exist. The sky is a museum of light from the past, and even the nearest objects in it are already history by the time you see them. Webb extends that logic to its extreme. The galaxy's Webb photographs in its deepest images are not just distant in space. They are so distant that looking at them is looking at a universe that existed before this solar system was born. You are, in a literal and physical sense, looking at your own deep past. Now for the thing that sits outside the bubble entirely. There is a phenomenon that cosmologists have measured and named, but cannot explain through any mechanism currently in the standard model. Entire clusters of galaxies, not individual galaxies, but enormous collections of them, are drifting together in a shared direction. They're being pulled, as far as anyone can tell, towards something. The motion is too large, too consistent, and too widespread to be explained by anything visible inside the observable universe. The gravitational source that would be needed to produce this drift on this scale does not appear to exist anywhere we can see. The leading explanation, and it is the kind of explanation that takes a moment to sit with properly, is that the source is outside the observable universe. Something beyond the edge of our bubble. Something whose light will never reach us. Something we cannot observe by any direct means, is exerting a gravitational influence on the matter inside our bubble. We can measure the shadow it casts. We can detect its pull on the things it is tugging, but we will never see it directly. The universe we can observe is not reacting only to itself. It is being shaped, at least in part, by something permanently beyond the limits of human perception. This is what cosmologists call dark flow. And it is one of several pieces of evidence suggesting that the observable universe is less a complete picture and more a small, lit room inside a much larger and mostly dark building. The room is all we will ever have access to. The building has no known size. Webb's role in all of this is specific and important. It did not invent these mysteries. The Hubble tension existed before Webb launched. The possibility of structure beyond the observable horizon was theoretical long before Webb took its first image. What Webb did is bring the data into sharper focus in a way that makes the problems harder to explain away. The impossible early galaxies became undeniable. The scale of the structure visible in deep field images reinforced the sense of a universe that organizes itself in ways that look almost deliberate. Vast filaments of matter connecting galaxy clusters across distances that dwarf anything in ordinary human experience, with enormous empty voids between them. A pattern that repeats at scale after scale, like something you would expect to see in a nervous system or a network, not in random matter left over from an explosion. Nobody knows what generated that pattern. Dark matter plays a role. The initial conditions of the universe play a role. But the specific architecture, the specific way everything arranged itself, remains one of the open and genuinely difficult questions in cosmology. Here is where the story turns personal, and it has to, because none of this is worth anything if it stays abstract. Everything you are made of was forged inside stars. The carbon in your cells, the iron in your blood, the calcium in your bones, these elements did not exist when the universe began. They were built inside nuclear furnaces that burned for millions of years and then collapsed and scattered their contents across space. You are a later version of the universe, a later version of it, built from the same material, a physical continuation of it. The same matter that was plasma at the start of time eventually organized itself into something that can look back at its own origin. That is not a comforting metaphor. That is the actual physical sequence of events that produced you. And when Webb photographs light from 13 billion years ago, it is, in a strange but genuine sense, the universe has built instruments from its own materials and turned them on itself. The philosophical weight of that cuts in two directions at once. On one side, you are a temporary arrangement of atoms on a small planet orbiting an ordinary star in a galaxy that is one of hundreds of billions in an observable universe that may itself be a small pocket of something larger. Your individual concerns on that scale are dimensionally invisible. The universe arranged itself for nothing in particular. It had no plan, no destination, no preference for your existence. You emerged from a process with no author and no audience. On the other side, that is exactly what makes awareness so striking. The universe is not required to produce anything that looks back at it. For most of cosmic history, it did not. Plasma does not wonder about its origins. Gas clouds do not ask questions about the scale of what they belong to. At some point, matter organized itself into something complex enough to develop the capacity to be curious, and that capacity is, as far as we can tell, extremely rare. The observable universe is vast beyond any useful description, and the places in it where the universe is currently aware of itself may be vanishingly few. You are living in the window when that is possible. The stars are in a phase of their life cycle where they burn stably and provide the steady energy that allows complex chemistry and complex life to exist. That window is real. It opens slowly and it will close. In the long view of cosmic time, measured against the full life cycle of the universe, We are in a brief era of conditions that permit the kind of organized matter that can sit on a planet and feel confused about how big everything is. Webb is a product of that window. It is a machine built by curious matter aimed at the darkness. It asks what is out there. The answers it is returning are uncomfortable in the best possible way. They confirm that the universe is larger than our models described. They suggest that things formed faster and stranger than the timeline allowed for. They hint at forces and structures beyond the edge of what we can ever directly observe. And they do all of this without resolving the tension. The dark flow source is still unknown. The impossible early galaxies are still unexplained. The Hubble tension is still unresolved. The models are still broken in ways that have not been fixed. The universe has been building toward this for nearly 14 billion years. It ran through billions of generations of stars just to produce the chemistry that eventually produced you. That is either the most important thing that has ever happened, or it is entirely meaningless. The evidence supports both conclusions equally. You get to decide which one you carry. That is the actual state of cosmology in the era of Webb, the honest kind of ending. The question of the universe's true size and shape remains open. A sharper picture of how much the existing answers were incomplete, and a set of new questions that are genuinely harder and more interesting than the ones they replaced. The grain of sand is still worth holding up. The darkness behind it still contains thousands of galaxies you will never visit. Those galaxies were made of elements, forged in fires, that burned and died before this world existed. They carry light that has been traveling longer than this planet has been solid. That light arrives now, at this mirror, at this moment, caught and turned into an image by a species that had no business existing at all. And yet here we are,